Before we continue, I would like to briefly describe the Apache Web Server. It's a popular open source web server, and it's one of the technologies that in the Flash paper the authors compare against. My intent is not to give a detailed lecture on Apache, that's beyond the scope of the course, but instead I want to give you enough about the architecture of Apache and how it compares to the models that we discussed in the class. And also the other way around to understand how these discussions in class are reflected in real-world designs. From a very high level, the software architecture of Apache looks like this. The core component provides the basic server-like capabilities. So this is accepting connections and managing concurrency. The various modules correspond to different types of functionality that is executed on each request. The specific Apache deployment can be configured to include different types of modules. For instance, you can have certain security features, some management of dynamic content, or even some of the modules are really responsible for more basic HTTP request processing. The flow of control is sort of similar to the event-driven model that we saw in the sense that each request passes through all of the modules. Like in the event-driven model, each request ultimately passed through all the handlers. However, Apache is a combination of a multi-process and a multi-threaded model. In Apache, a single process, a single instance, is internally a multi-threaded boss workers process that has dynamic management of the number of threads. There are some configurable thresholds that can be used to dynamically track when to increase or decrease the number of threads in the pool. The total number of processes, so the MP part of the model, can also be dynamically adjusted. And for these, it's information such as number of outstanding connections, number of pending requests, CPU usage. A number of factors can drive how the number of threads per process and the total number of processes are adjusted.